Okay, so that other day we did a couple of questions, and this was the next question. So here we are given a diagram, and then we are told that AQ, this is Q over here, AQ is parallel to BP. BP is down here, so you can see those three parallel lines or parallel indicators. And then you have AB, this is AB is parallel to DC, this is DC. You have QP, this line is parallel to AC over here. So this is these two. We have one parallel indicator. It means it's parallel to this one. You have three parallel indicators. It means it's parallel to this one. You have two parallel indicators. It means it's parallel to this one. So it's easier to spot that way. Also, you're told that AB, this line, it's equals to BC, which is this line over here. And also we are told that ADC, this angle is 112, and QPA, this angle over here is 20 degrees. We're supposed to determine the magnitude of AOD. So AOD, this angle over here. That's what we are tasked with finding. All right.
Sir,
Good
day. I can't see your screen. Sir.
Can everyone else see the screen?
No.
Yes.
Yes.
Okay, those who can't see, can you exit and try joining in again? Still can't see it. Can you see it now? Are you able to see it now? Okay, I guess that's a yes. People are quiet. All right. So firstly, what we're trying to do, like I said, we're trying to find out what's the value of this angle over here. So to do that, we're gonna utilize the things we know about our shapes. So immediately, if this line over here, this line is parallel to that line, this line is parallel to that line, can we say that that's a parallelogram? It has opposite sides being parallel to each other. Do we agree?
Yes.
All right,
Yes,
so A, B, C, D is a parallelogram. It's a parallelogram, right? So we know that the opposite angles in a parallelogram, this and that, like that, are equal, right? So we can say in parallelogram ABCD, angle D, it's equals to angle B, and then we can say those are opposite angles of a parallelogram. Parallelogram, right? Therefore, we can say that angle B over there is 112, right? So we now know the value of this angle. So the approach that I'm trying to take here, I'm trying to find a way whereby I can calculate the value of this small angle over here. Can you see that? Yes, I'm trying to find a way whereby I can calculate that small angle over there. So right now, the approach that I'm using is that we now have this one as 112. Since this and that, these two sides are equal, that means that side, that angle over there, and that angle over there are equal. That means I can be able to find the value of this corner angle over here, right? Next, what I'll do, I'll check for this. So here I have not visible. Here I have a Z over here for this 20 and that angle over there. So this as well, I can say it's 20. We'll calculate it properly. That one as well, I can say it's 20. Are we still all together? So that means, firstly, I'm gonna get this guy over here. After getting it, I'm gonna declare that this part is 20. After that, I'll have a U shape that I will deal with over here. Yeah, I'll show you. It's just showing you the approach that I was gonna use. All right, so here we have that. Everyone happy with that 112? This guy is that guy on this shape. Right, moving on. Then we can say angle A, not A, angle CAO or angle CAP. So we can say
Yes, sir.
CAP. This angle over here is the same as that angle over there. It's equals to APO, like that. The reason for that, those are alternating angles, right? We have a Z or an N here. So we can say those are alternating angles. That's because AC is parallel to PO or O. No, it's not O, it's Q, sorry. Q, that means this is also Q, like that. Right. So that's what we can say about that. So that means, therefore, CAP, it's equals to 20. So that means here we have 20. Let's erase and clear that up. So here is 20 degrees. Here it's 112. This one I don't know. After finding this one, then I can say I can use this small triangle over here to get this angle over there. Right, which is what I'm actually looking for. So that's 20. And then I can say now, let's move this a bit. This. All right. So now we can say we are looking for this angle here. So we can say in triangle ABC, and this triangle over here, AB is equals to BC. This was given on the statement, so it's somewhere there. AB is equals to BC, and then we can say therefore angle A is equals to angle C. So this angle will be the same as that angle. The reason for that would be those are angles opposite equal sides. Angles opposite equal sides, like that. So we have those, and then we can move on and say if we will add angle A plus angle B plus angle C, we'll get this as 180 degrees, like that. So this will be the sum of interior angles of a triangle, right? So here we know angle A plus, we can say this is 2 angle B. We can say it's 2 angle B because, or not angle B, wait. Oh, can use 2 angle C. And then that means this has to be B, sorry. like that. We are saying angle C because we have concluded that A and C are the same. So these ended up being like terms. So end up like this. It's equals to 180. We know the value of angle B. It was 112 plus 2C. It's equals to 180. 2C, it's equals to 180 minus 112. What do we get there? 180 minus 112?
68.
68. So we'll have 68. We are solving for C, so we'll divide by 2. Over there, we end up with angle C being equals to 30 what? 34, I think.
34.
34. So that means here, I know this is 34. Also, this is 34. So now if I'll check and look at this corner over here, I have 34. Let's try and redraw it. I have 34, I have 20, and then I have this angle over here that I don't know. That's what I'm going to try and find. Right. Let's see how we can do that. So we will look at this shape. This one. These two lines are parallel. We have a U shape over here. So what do we call that U shape in parallel lines? What type of angles are those?
Aksama co-interior.
Co-interior, and they add up to?
They add up to 308.
180, yes. So we can say angle A, we can say angle A plus angle D, it's equals to 180. And then we can say, even if we don't call it angle D, let's specify the actual angle. So angle A, because the whole of angle A, we are using the whole of it. And then we're using A, D, C, it's equals to 180. And then from there, we said the angle, the reason was those are called interior angles. Right, angle A, for us to have angle A, we have to take this 34, this 20, and this unknown. So we have 34 plus 20 plus, we can call this X or we can call it Y, it's fine. And then plus this ADC, it's 112, it's equals to 180 like that. Right. Then from here we have Y, it's equals to 180 minus 112 minus, I think that's 54. So what do we have? 180 minus, what do we have?
14.
14. So
Yes.
we have 14 like that. So that means this small onion space over here is 14. So now if we take a look at a triangle ADO. So this is D, this is 112, this is 14, this is A, this is O. The angle that we are asked to find is AOD. So we're trying to find this angle over here. So we can say in triangle AOD, we can say angle A plus angle O plus angle D is equals to 180, and that's the sum of interior angles of a triangle. And then from there, angle A, we know that is 14. Angle O, we can write it as angle O because we don't know it. Angle D, it's 112, equals to 180. So angle O will be 180 minus 112 minus 14 like that. What do we get? (180 minus 112 minus 14), what do we get?
54.
54. So that means this is 54. So therefore we can say what's the not triangle, but that angle, which is AOD, it's equals to 54, and we are done like that. Any questions on that one?
Yeah.
Any questions?
Yeah, ngicela i-screen usilike. Uzoom out kancane.
Esasiboni kahle. Vile kancane.
And right now,
Yes,
Yeah, says zoom out.
again,
Zoom in guys. Stubborn. Yeah, no, it's okay.
nibhala ngapha kule side.
Mm.
All right, just to
Okay.
recap what we did. Just to recap what we did, where's that question? So what we did here, we first found out this angle over here, angle B, by saying that ABCD is a parallelogram. So that angle is equal to this angle over here. After that, we took this 20 and placed it over here. And then we said those were alternating angles. We were trying to get this whole angle over here. So we were now missing this guy. And we said this guy and that guy, A and C, are equal because this is now an isosceles triangle. If it's an isosceles triangle, the angles opposite equal sides are equal. So we ended up getting this as, what did you get this as? 30 something. Got this as 30 something, 34. And then we have 20 over here. We can find this angle over here. So we found this angle by taking angle A and angle D over here as co-interior angles. They form a U, and then from there we add them and get equals to 180. So doing that, we found out that that small space over there is 14. After that, we look at this triangle over here, ADO or AOD. We have 112, we have 14, we have an unknown over here. And then we just use the sum of interior angles of a triangle, and then we got what we were looking for. Any questions? Right. Next, we have this question. We are told that it's number 10. I think it's on page 3 for you guys there. We are told that ABCD is a parallelogram. So immediately it's a parallelogram. That means I know this side is parallel to that side. This side is parallel to this side. This side it's equals to that side. This side it's equals to that side. Before I do anything else, I can note those. All right. And then we are told that E is a point on AD, there's E, such that AE is equals to AB, that has been marked for us. And we hear that E, what's this? CE, this one, or EC, it's equals to CD over here, right? And then we're also given that BEC, this angle over here, it's equals to 90. We're supposed to calculate the value of EBC. So EBC. So we're trying to find this angle over here.
You are rushing, Sam.
I'm rushing. All right. We are saying that this is a parallelogram. Everyone happy there? So I
Yes.
mark the parallelogram properties that I know. This line over here is parallel to this line. This line over here is parallel to that line. So I've marked those parallel like that. After that, I know that this line has to be equal to that line. This line has to be equal to that line. So I marked those as well.
Yes.
Right. After that, we are told that E, this is point E, is on AD such that AE, where is AE? This side, it's equals to AB, that side. And EC, which is this side, it's equals to CD, which is that side. That's all from the statement. Also, we have seen that BEC, which is this angle over here, it's equals to 90. They've indicated with a square over there. We are supposed to calculate the value of EBC. So EBC is over here. Right. Any questions?
Nope.
All right. So remember what was, let me just remark this properly. So this part, it's equals to that. We said this is equals to that. And parallel, like that. Right. So first things first, I know that this side is equals to that side. That means this angle will end up being equal to that angle. Do we agree?
Yes.
Also, this side
Yes,
is
sir.
equal to that side. That means this angle will also be equals to that angle. So we are noting things that we know so that when we go through the problem, we are able to use those to actually help us. Right. Next, we cannot say that this is an alternating angle because this line is not parallel. It's not parallel to this line. We also cannot say that this is an alternating angle because this line is not parallel to this line over here. Right. So let's move on. So what I can do, I can say let this EBC to be equals to X, or can use Y. I think my Y is better. Y like that. So that this will prevent me from writing EBC. It's going to take a lot of time. So what we are saying now is that EBC, this guy is Y over here. Right. So what I know about this triangle, I know that I can add up the angles in this triangle and get 180. So I can say in triangle BEC, if I add up angle B plus angle E plus angle C, I'm gonna get 180 like that. This is the sum of interior angles in a triangle. Right. From there, angle B, I said that was Y. Angle E, I'm given as 90 plus angle C, I don't know what angle C is. It's equals to 180. So I can say my angle C is 180 minus 90 minus Y. So my angle C is 90 minus Y. So I have this guy. So now I know the value of this guy is 90 minus Y. Right, so let's move on. From there, what I can find out, or what I can see, is yellow visible? No, yellow is not visible. Let's try green. This forms the Z over there. Can you see that?
Yes.
Right, so that means this guy and that guy are equal, and those would be alternating angles. Right, let's move on. So we'll say angle BCE, it's equals to angle CED, and those are alternating angles because AD is parallel to BC, like that. So that means this angle as well, it's also 90 minus Y, right? And then you remember that earlier on we marked this. We said this angle was equal to that angle. Do you remember that? Hello? We said these two angles were equal because of this over there. So we can say in triangle CED, angle E is equals to angle D, and this, the reason for this, it's angles opposite equal sides. So angles opposite equal sides are equal. So that one and that one we know. This one we don't know over here. So we can leave it like that for now. So still in this triangle, let's see, we can do sum of interior angles. Let's see. Okay, we're trying to get the value of y. Let's see if anything will be useful. So angle C, we don't know it. Let's just see if we can find something. All right, so we can call this angle P or something. Well, actually we are still in triangle CED, so we call this C. It's fine. Let's use C. So this angle is C. So in this triangle over here, I need more space. So this. All right. In this triangle, in triangle CED, we can say angle C plus angle E plus angle D is equals to 180 like that. It's equals to 180 like that. Are we still together?
Yes, sir.
Yes, sir.
All right, our C is unknown, our E and D are the same. So we'll have E 2 times E, it's equals to 180. We have angle C, it's equals to 2 times, not equal to, but plus 2 times E. We said our E value was actually Y, so it was 90 minus Y, like this. It's equals to 180. Right. Then from here, we can say our angle C will be equals to 180 minus 2 into 90 minus Y. So angle C, it's just 180 minus, this is 180 plus 2Y. So angle C, it's just 2Y. So the angle here, it's 2Y, like that. Right. So now if we check, let me see which angle can we use, which angle can we use. We said this one was, what was the value of this one? It was Y, right? This was 90 minus Y. This was also 90 minus Y, and so on. All right, so let's check something else. In this triangle over here, ABE, in triangle ABE, or even before that, and you see that we have a Z here. So that means this guy and that guy are equal, right? Hello? Angle AEB, it's equals to angle ABC, which both are equals to Y. We said the reason for this is alternating angles. AD is parallel to BC, like that. So now that means this is also Y. Let me use a different pen. This is now also Y. So we also marked that this and that are equal earlier on. So that means this is also Y. So we can say in triangle, what's this? ABE, angle B, it's equals to angle E. And the reason for that was angles opposite equal sides, like that. So this and that are the same, right? Also, we can say if I'm going to take angle A, adding it to angle, let me see. Actually, we don't. This one is fine. This is fine, I guess. We don't need to go that route. Right. So if you have been following, you will see that here we have a U that we can now use. There's a U here. This part is parallel to that line. So that means this angle over here and that angle over there are called what? Co-interior, right? So we can say we are taking, there was a B here. So as you can say that we're taking angle B plus angle C, angle B plus angle C, the whole of angle C to be equals to 180. The reason for that, those are co-interior angles. Angle B has this Y over here, the Y we just calculated. So it has the Y here, it has a Y here, it has a 90 minus Y, it has a 2Y over here. So B is Y plus Y. This is B. And then for C, it's 90 minus Y plus this 2Y over here. It's equals to 180. Then from there, collecting like terms, I think I end up with 3Y. It's equals to 180 minus 90. I have 3Y. It's equals to 90. I divide by 3. I divide by 3. My Y is equals to 30. Therefore, I can conclude that my angle EBC it's equals to 30 degrees, like that. Any questions? So again, what we were trying to achieve here, we were trying to find this angle over here. So I said that let me just assign this to be equals to Y. And then I looked at this triangle over here. I said, okay, if I have 90, I have Y, this has to be 90 minus Y. We calculated that, we found that this part out. After that, I said, okay, since this line is parallel to that line, that means this angle over here is the same as that angle over there on top, because those are alternating angles. That means this is also 90 minus Y. After that, I was like, okay, since this side is equals to that side, then I can now say this side, this angle over here, it's also 90 minus Y. Because those are angles opposite equal sides. After that, I found the sum of interior angles on this triangle over here to be equals to 180. So this is that calculation over here. And then I found that this guy over here is 2Y. And then now I had 2Y, I had 90 minus Y. I had to find this angle over here. To do that, I couldn't assume that this is a diagonal bisecting this equally, blah, blah, blah. So I first had to check that this forms a Z over here. So that means this is Y as well. Alternating angles. And then this side is equals to this side. That means this angle is equals to that angle. So that means this is also Y, because these are all angles opposite equal sides. So now I have this angle, this angle, and that angle. So from there, I said this forms a U. This now forms a U. This now forms a U. like that. So co-interior angles. So I did that co-interior angles over here. I substituted whatever I know, and then I continued solving for y. And then I remembered to return what I was asked to calculate, which was E, BC, not y, which is equals to 30 degrees. Any questions? Any questions?
No, sir.
All right. So I think that was, what time is it now? Okay, I think we can still type in another question. All right, the next pages that you're given there are just proofs that can be asked, that you can be asked to sort of prove in an exam. So your role is to just go through those and try to understand. I can try and explain them. So what's happening here is that you are asked to prove that the opposite sides and angles of a parallelogram are equal. So RTP is required to prove. So whenever you see RTP, just know it means required to prove, right? So we're given that ABC D is a parallelogram. Required to prove, what you're required to prove, you're required to prove that this side is equal to that side, and this side is equal to that side. Also, that this angle over here, which one was it? BAD, this angle over here, it's equals to BCD, and also angle B, it's equals to angle D, right? So the construction part, they drew this line, so you're able to construct or add your own lines as long as they'll be helpful. So we constructed a line which they drew AC, and also they drew BD. Where's BD? Oh, they didn't show it over here. So this is BD, but they're supposed to draw it over here. And then from there, you're saying in triangle A, BC, this triangle over here, and triangle CDA, that triangle, you try to prove that those two are congruent. If you will prove that those two are congruent, you can now say that side is the same as that side is the same as that side. That means you're done with the sides. You can also say the angles, this angle is the same as that angle, and then you have to continue with the other angle, but it's fine. So angle A1, it's equals to angle 2, what's this? A2, this angle, it's equals to C1. So you have alternating angles there because AB is parallel to CD like that. So this one is equals to that one. Also, A1, it's equals to C2, another alternating angle over here. And then from there, AC is common. So you have proved that these two triangles are congruent. Your reason for that, it's angle, angle, and a side. After doing that, you can conclude that AB is the same as CD, BC is the same as AD. And then from there, you can now say this angle, which is angle B, is the same as angle D. And the reason for all of this is because these two are congruent triangles. Any questions there?
Can you please repeat what you have just said?
I can't hear you.
Can you please repeat what you have just said?
All right. Did you hear the congruency parts?
Yeah.
All right. So we said that AB is now equal to CD, which is this part, and BC is equals to AD. Also, this angle, which is angle B, is equals to angle D. And all of those from the part whereby we are saying that those two triangles are congruent. Right. Then from there, we now saying that A1, if I'm going to add A1 plus A2, I'm going to get C1 and C2. The reason for that is that already this one is equals to that one, this one is equals to that one. So if you're going to say, if you're going to add these and these, you're going to get that thing, that those two angles are the same, like that. So therefore, you can now conclude that BAD, which is this whole angle, is the same as BCD, which is this whole angle. So you have proved that this is a parallelogram, and you have proved that the opposite sides and their opposite angles are equal. So what you have to note is that most of the time when they have to say prove something related to sides, you have to use congruency. So you have to go back to congruency and use that. All right. The second proof, we are asked to prove that the diagonals of a parallelogram bisect each other. So there you have your diagonals like that. So you're given a parallelogram ABCD with diagonals AC and BC. They're intersecting at E. So they intersect here at E. And then you're supposed to prove, required to prove that AE, this side, is equals to EC, and that BE, which is this side, it's equals to AD, like that. So like I said, if you'll be dealing with proving sides, you have to go to C. So in triangle ABE, this triangle over here, and triangle CDE, this triangle over here, you can say A2, it's equals to C1. Those are alternating angles. We have a Z there. You can say B1, it's equals to D2. You also have another Z there, Z or N, like that. Next, you can say that they said that AB, this is AB, is equals to CD. The reason for that, we said opposite sides of a parallelogram are equal. So that's why we are saying that AB is equals to CD. From there, I can now conclude that triangle ABE and triangle CDE are congruent because I've proved that a side, which was this one and that one, another side, which was the other side? It's supposed to be angle here. An angle and an angle on the side. Okay, so an angle, we proved this angle, we proved this angle, and we proved this side. So that's angle, angle, and the side is for congruence. And then from there, I can now say, therefore, AE, where is AE? This is equals to that. And then, AE is equals to this side. And BE, this is BE, it's equals to ED, which is that one over there. Right, as you can see, our proofs rely mostly on congruency. So you go back to congruency if you're asked to find something that has to do with sides. All right, another proof that you might have to do is supposed to prove that if one pair of opposite sides of a quadrilateral are equal and parallel, then the quadrilateral is a parallelogram. So if you can only prove that one pair, you can prove AD and BC that they are equal and parallel, then this whole shape is a parallelogram, right? So you're given this quadrilateral ABC D, and you're told that AD is parallel to BC, and also you're told that AD is equals to BC. Supposed to prove that this is a parallelogram. So what they did, they first did some construction. They drew a diagonal AC. This is diagonal AC over here. And then from there, you're supposed to check triangle ABC is this one, and triangle CDE DA is that one. We're doing congruency here. So C2, it's equals to A1. Those are alternating angles. AC is common. It appears on both triangles. And then BC, this is BC, is equals to AD. That was given for us. And then you can conclude that those two triangles are congruent because you managed to prove a side, an angle, and a side. Next, you can therefore conclude that A2 is the same as C1 because these two triangles are congruent. And then let me say, therefore, AB, therefore this side is parallel to this side because you're having this guy and that guy, A2 and C1 being equal. So we can say that AB and CD are parallel because they're giving us these two as alternating angles. Therefore, you have proven that this is a parallelogram. Any questions on that one?
Nope.
All right, so you do have those proofs with you. You can go through them, and I'm hoping these will serve as a guide to see how to actually go about solving problems. So most of the cases you see that congruency is there. All right. Also, this one is another proof. Prove that the diagonals of a rectangle are equal. So we're supposed to prove that AC and BD are equal. So there's your proof over there. Another one, prove that the diagonals of a rhombus bisect each other at right angles, and they bisect the interior angles of the rhombus. So that's the proof over here. Right. The other thing, it's a midpoint theorem. They're saying it's not examinable. You just have to know it, that if you're having a line segment that joins two midpoints, so the midpoint for AB is D, the midpoint for AC is E. So if you have a line joining those two midpoints, which is DE, that line would be parallel to BC. That's what we're saying over there. So that's the midpoint theorem. If you have a segment or a line joining the midpoints of two sides, then that segment is parallel to any other line down there, something like that. So this is the proof for it, but like they said, it's not examinable, so they won't ask you to prove the midpoint theorem. You can go through this just to see how proofs are done. Right. So midpoint theorem, we are saying that if D is the midpoint, is in the middle of this line, and E is in the middle of that line, hence we can say that this part is equal to that one is equal to that one. Therefore, we can conclude that this line is parallel to that line. That's your midpoint theorem. So that's on page 6. Midpoint theorem, there you go. So questions relating to midpoint theorem, you have this one over here. We can try it quickly just to see what is what. And yeah, people can go rest. Okay. Where's my pen? So here we are told that we are given that AD, this is AD over here, it's 5 centimeters. MC over here is 6 centimeters. Like that. Supposed to calculate with the reasons the length of BM is somewhere here, DP is somewhere here, and DE is somewhere here. Right. So for BM BM is located over here. We know something about AD. AD is over here, it's 5. And we know something about MC, which is over here. Or MC or CM as 6. Right. So let's see if we are able to get that side over there. Right. So if we check, let me see, which triangle should we check? Which triangle should we check? Because we don't have this part over here. All right, let's see. So we are told that this line is parallel to that line. So that means we can say that AD it's equals to MD. This line is parallel to that line. So we can say, I think we can just say midpoint theorem. Midpoint theorem, like that. So this one is equals to this one. So that means here it's 5. So MD it's equals to 5 centimeters like that. So this guy is equals to that one, right? After that, let's see which other triangle we can use. On this triangle, you have this side parallel to this side. It means that this guy is equals to that one. That means M here is still a midpoint. So you can still say MD it's equals to BM, midpoint theorem as well. And then that means BM it's equals to 5. So we are done there. Moving on for DP. DP is over here. We are given that this side is already parallel to this side. So the third side on your midpoint theorem, this one is 2 times this segment over here. So we can say DP it's equals to 2 times DP it's equals to MC, and then we can say that's still midpoint theorem. And then trying to get DP, so we can divide by 2. So DP would be MC, which is 6 divided by 2. So DP is just 3 centimeters like that. DE, where's DE? Is that whole side? So since this is the longer side, the third side of the triangle compared to this one, we can say 2MC, same calculation as this one. It's equals to DE, midpoint theorem as well. That means we can say 2MC is 6, it's equals to DE. Therefore, DE is equals to 12 centimeters, something like that. So your midpoint theorem, it's around understanding the part that if you have this line being parallel to that line, it means that this guy is equals to that guy is equals to that guy. If you're looking at this red triangle, we also have other triangles over here, a lot of them. So we can apply the midpoint theorem throughout. So you do have some of those questions. Yeah, you do have a bunch of questions to go through. Yeah, but I think I'm gonna give you those ones for practice. You get stuck, you ask on the group, and we will assist where possible. Right. So tomorrow, I'm thinking we will tackle some algebra or analytical geometry or trigonometry. We will see tomorrow.
So also the class tomorrow.
Yes, we have a class tomorrow.
Friday.
Class. Saturday.
Class.
in class, and then in the evening I won't see you Saturday. We'll do it Sunday, and so on and so on. There's a lot that you guys need to do.
Did you have a class on Friday?
Yes.
So can I ask, when are you doing linear functions?
Linear functions. Talking about y equals to mx plus c.
Yes.
I think we still need to finish analytical geometry in class first. So hence these evening classes, I'm trying to ensure that we are able to cover some work and we're able to actually see how questions are done. And people are not being left behind. All right, any other questions? Any other questions?
No, sir.
All right, we'll meet tomorrow and then we'll just find a topic that we can do. Algebra or trigonometry or analytical geometry. But analytical geometry, I can't do it here because a lot of you guys are not here. So that means that one I have to continue that one in class. So we'll continue covering revision over the evenings. And hopefully when your June tests or June exam arrives, you are ready.
When you said you're para Friday.
Nepala on Friday.
They said it's about trigonometry and geometry.
And geometry.
Yeah.
Yes, so that means if you have attended these past few days, that means for your geometry, you'll be having an idea on what to write now. All right, anything else?
Nope.
All right, cheers then.